that elements are organized into different blocks on the periodic table according to their... So recall that electrons in the highest principal energy levels are called valence electrons. And group 1 elements all have one valence electron. What I'd like you to do is I'd like you to take a moment and fill in that last column for me. All right, ladies and gentlemen, as we're coming closer to finishing these, what I want to do is just take a look at the very ending of each one and notice that the first one has a 1 in front of it, the first thing. The second one has a 2 in front of it. The third one has a 3 and the fourth one has a 4. Sarah?
Is it because they're in period 2?
It is. This is the first period, second period, third period, fourth period. That's exactly right. This first number is the periods. Excellent. And then S we're going to talk about in a moment. But S is the block that it's in. But this is the same as this over here, and this down here is the same as this. And this is the same as this. And I'm going to show you how that's done. In other words, writing this is a little bit easier. You'll notice that the 1s1 appears here at the very end. And the 2s1 appears here at the very end. The 3s1 appears here, and the 4s1 appears here. Well, what that means is that the HE is really everything except for that last one. And that the NE is everything except this last one. And the AR is everything except this last one. So we're sort of writing abbreviated versions over here. And so if we go from 1s1 helium to S1, well, the first thing I want to say about the blocks is I want to tell you about the S block. The S block is over here. The S block are the first 2 families on your periodic table. And they're kind of set apart. This whole thing over here is the S block. And it holds 2 in it. And so over here, you'll notice that all of these end with the S block. They're all ending in the S block over here. So now that we have the S block there, you'll notice there's the first one in the S blocks. It's S1. So there's 1 electron in that last S block. Everybody with me so far? Excellent. Let's fill in our table, the next part. So when we talk about the blocks of the periodic table, if you click on the Google drawing, then you can label each one of the arrows. The second block that we're going to label after S, we're going to skip over kind of in order. We're going to start at the top, and we're going to go from top to bottom and left to right. So as our elements go, we're going to go S block, and then S block again. This really should be over here. And then we have S block again, and then S block, and then the next block we come to is going to be the P block. So I'd like you to label the P block next, because we go S and then P, and then after the P, we go back to S again, over here, and then we go to P again, and then we do S, and then after we label the S and the P block, I'd like you to label your D block. That's here in the very center. So we have S, we have P, and we have D. And the last one, of course, is going to be F. S, P, D, and F. Follow along with me. We go S first, and then S again, and then back to S on the other side. S again, and then we start into P blocks. And then after P blocks, we go to S block. Hold on a second. I think I'm making a connection here. So we have S, and then we have S, and then we have S, and then we have P. Hold on a second. And then there's S again after the P. Just a minute. Just a minute. I'm making a connection here. Wait, then there's S, there's P, then S, P. After the P comes S again. Hold on a minute. I'm making a connection. So if I go S, then I go S again afterwards. Then I go P. Then I go to S again after P. Then I go to P again. And then I go to S again. And then I can go to D. And then what comes after D? Ah. On your periodic table now, we should be able to sort of count and figure out which elements are where. And by the way, how many does G have in it?
40.
What about S? How many does S have in it? And what about P?
6.
So we have 2 in the S, 2 in the S, we've got 6 in the P. 6 in the P, we've got 2 again in the S, another 6 in the P. Can you see that we only have a maximum of 6 in the P and a maximum of 2 in the S? So ladies and gentlemen, what we've got here is we've got lithium, or the electron configuration of lithium, really is the configuration of helium plus one more. So what I want you to do is to take a look with me over here on the periodic table as I count out lithium for us. And really, let's start with 1s1. 1s1 means the first period. And the first period is here. And the S block means this block over here. And the 1s superscript 1 means there's one electron there. So we have one electron in the first period of the S block. So then we can count out the second electron. This would be 1s1, and then we would go right to here, which is where helium really should be. It should be 1s2. So 1s1 and then 1s2, which is our configuration 1s2. You'll notice it's the beginning of lithium, 1s2, but then it's 2s1. So let's go back over here to lithium. We have 1s1, 1s2, and then we have 2s1. As we go all the way over, 1s1, 1s2, and then it's the second period, so we start with 2, 2s, and there's one electron, so 2s1. We could go 1s1, 1s2, 2s1, 2s2, and then after 2s2, what happens?
P.
We get 2, because it's the period 2, and then P block, and then 1 electron in there, so it becomes 2p1. And then this is 2p2, 2p3, 2p4, 2p5, and 2p6. So as we go across now, let's take a look at this one, which is the neon configuration plus 3s1. So we go 1s1, or excuse me, 1s2, which is our first period, then 2s2, which is our second period, and after the second period, we go into 2p6. We fill all the way through 2p6, which is neon. So we go 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Brings us to neon. And if we go one more, we always go up top to bottom, and we left to right. And as we go from neon, we start over here to sodium. This is going to be period 3, block S, with one electron in it. So over here we have 3s1 at the end. It's neon plus 3s1. Is everybody feeling that one? Let's take a look at potassium. Potassium is argon with 4s1. Let's look at argon. Here's argon. If we go to the next one, it's the argon configuration plus period 4, S1. The S block, 1 electron. Let's do the electron configuration of boron. Who can tell me the electron configuration of boron?
Take a moment now, pause the video, and try to work it out.
In this case, start with the noble gas that comes before it.
With your noble gas of helium, and count from helium, 2s1, 2s2, and then over to the D block to 2p1. Okay, let's try one more practice problem, and let's try doing the electron configuration for silicon. So we'll start here, and we'll write it all the way out this time. We'll start here with 1s1, 1s2, and then we'll go over here to 2s1, 2s2, and then over to 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. And then after 2p6, we go back over here to 3s1, 3s2, and then over here to 3p1, 3p2. And that is the one we're looking for. And that is the electron configuration for silicon. One more example problem here, and we'll take an element that's farther down the periodic table. Let's take bromine, and you'll notice here that we've got our 1s, 1s2 should be over here, but I've stuck it over here now. And 2s2, 2p, 3s, there's our 3p, there's our 4s, and then you'll notice something strange here. And once it goes 4s, then it goes 3d, then it goes back to 4p, and notice this D block is off by 1. It's whatever the period is minus 1. So let's try a practice problem with the electron configuration for bromine. I'll start with 1s1 and 1s2. And then 2s1 and 2s2. And then we'll do 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. And we'll do 3s1, 3s2. Then we'll do 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Then 4s1, 4s2. Then we'll go into the D block down here. And remember there are 10 in the D block. And so we'll go D 1 through 10, but instead of it being 4 in the fourth period, it's going to be 3, so it's actually the period minus 1. 3d1, 3d2, 3d3, 3d4, all the way through 3d10. And then we want to go, we're still in the fourth period now, so it's back to 4, 4p1, 4p2, 4p3, 4p4, and 4p5. That is the electron configuration for bromine.
If you thought you had it and now you're confused, don't worry, it's okay. We're going to go over this again next time. You'll probably be able to watch it on YouTube.
What?
Have a great day today. We'll see you next time.